Hello, my name is Kelly Doyle. This presentation is a demonstration of a proof of concept for Harvard Extension Class E599 Capstone Seminar in Digital Enterprise. As our capstone project, our team is building an application to record and track drug pharmaceuticals as they pass through the supply chain using blockchain technology, specifically private blockchain for business using IBM Hyperledger and Composer tools. We're going to describe our company's product. Our company is BlockMed, and I'm going to show you how we run the product using a private blockchain on my laptop. So first, I have a window where I've started the IBM Hyperledger fabric. This is running in Docker containers and is simulating, actually working as it would work in the IBM cloud, running a blockchain peer network. In this window, I'm running a REST API that's provided as part of the IBM Composer tools that will allow me to access the blockchain through REST APIs and the entities that I've defined, and as well as the transactions that I've defined in chain code or smart contracts. And lastly, there's a window where I'm capturing any events that are generated as a result of those smart contracts. So now that we know what processes are running, let's take a look at our entities that I've already preloaded before this presentation started. So I have preloaded entities using the REST APIs by calling REST endpoints with simple contracts where I've loaded partner definitions, locations, and products, which are our pharmaceutical products, as well as batches. Batches are useful for issuing recalls. And items, in this case, a trade item is a product in a specific form factor or package, for example, a specific pill count or pill size. An individual package is how we define the smallest unit that were trackable in the BlockMed application at this time. So this is an individual package, say a specific box of aspirin that I purchased at a pharmacy today. And we're going to be able to track that through the system. We also have shipping containers. Individual packages are packed into shipping containers, and we track the actual containers as they move throughout the system. Let's take a look at our transactions that I've already submitted. So I've submitted some transactions to package individual packages into a shipping container and to execute the delivery and the receipt of those shipping containers at loading docks and unpacking them, and we're tracking the individual tracking numbers at that point. Let's take a look at our REST API. So as I alluded to earlier, the REST API is bootstrapped or scaffolded by the IBM Composer tools, along with a user interface, a Swagger implementation that allows us to read and even submit data. So for example, by invoking this REST API, I can see JSON format of all the individual package entries that I've already created. And I see that for each entity. This visibility record is an entity that we've used in order to bubble up all of the different transactions into one entity that can be easily and quickly searched with high performance. So regardless of whether it was a package transaction, a shipping, or a receipt, I can invoke one query filtered on certain parameters, and I can see all the visibility events as something moves through the system. And the last thing that I want to look at here are some of the system REST APIs that we get out of the box, including the historian, which gives us pretty much a raw view of the data that's stored in the blockchain itself. So while the blockchain data is immutable, we have a world state that represents our application domain state at the time. The blockchain state itself is simply a ledger of additive requests that happen over time. And this is the part that gives us the transparency and the stability and the irrefutability of our data. Obviously, having these REST APIs is very useful and compelling, but for our user interface, we want to supply the ability to query these through a user interface, which we'll look at a moment. Before we look at that, let's take a look at how the chain code is implemented under the covers. So our chain code consists of JavaScript code. Chain code is synonymous with smart contracts in our implementation. And for example, when I issue a ship package request, it's going to invoke this smart contract, which is going to create a visibility entity, set some data, copy certain data, validate certain data. And one of the things that it's going to do as a side effect here is it's going to emit an event. So the blockchain can emit an event that other applications or our partners can listen for and take some other actions when something's received as well. Having looked at some of the behind-the-scenes code, let's now take a look at an example BlockMed application. So I've scaffolded up an Angular application that works on top of the REST APIs that will allow us to quickly search and even potentially manipulate some of this data. We're going to search for a visibility event for a specific product. Now we track our products through something called a serialized GTIN number. These numbers are based on a standard called EPSIS, which is used to track supply chain data, not just for pharmaceuticals, but for other supply chains as well. In this case, we're basing our solution off of standards such as the SGTIN, which is an individual package tracking number, so a globally unique number. I'm going to search for this product. You can imagine I could be using a scanning code or a mobile device here. And I can see results for this product. So I can immediately see details about the batch that it came from, where it was manufactured, and who manufactured it. And I can see it tracked throughout the entire system from when it's packaged into a container, shipped throughout the supply chain through different partners, finally received at a pharmacy, and unpacked. And I can view details at any of those steps and see information such as a universally unique transaction ID and other useful information. Now, I'm going to take a look at another product that I happen to know the ID of. And this one has a shorter supply chain record right now, and we're going to add to this in real time. So in order to do that, I'm going to duplicate a transaction. I have this one ready to go. So for container number SSCC-0002, it was last recorded as being received at this location, 04-L01. I'm going to add a transaction that ships it out of 04-L01 to head to its next location on the next day. So I'm going to copy this. This is a simple curl request. So an HTTP REST request. And I've gotten a response. It looks like the transaction went through. And I've seen an event come through on my event listener through WebSockets as well. So this should allow me to see in the user interface as well that this has arrived somewhere. And I can see, that I've shipped it out of that location as expected. It's on its way to its next location. So again, using blockchain technology behind the scenes, and I hope you can see that it's a compelling, and this is all running on my laptop. It would be highly performant in production, and it's really provides a great solution for partners being able to track drugs throughout the supply chain. Thank you.